You're a race car, but you're a hybrid electric race car. And so you're green, but you're fast and you're fun.
Our project is the Formula SAE Michigan Hybrid Racing Team.
What we did is we looked around and we tried to see what we could do that incorporated a lot of mechanical and electrical concepts together. And we ended up finding the Formula Hybrid competition.
The goal of the competition is that it is a business pitch. You're designing a prototype and you're trying to pitch it to big name auto companies.
It's sponsored by Formula SAE. We're building a half-scale Formula One race car that's a hybrid.
So our goals with our project is to design a vehicle that people would be interested in, would have fun driving, would sell well, and that has amazing acceleration, really good fuel economy, and can go a long distance.
It's going to be huge trying to eke out not only as much power as possible when it comes to the acceleration events, as well as the autocross event, but then you have the endurance event where you need to be as efficient as possible. So it's kind of being able to switch between power and efficiency. It's very simple mechanically to set up, but then what's going on in the computer is going to be real magic. If we progress and this team gets done fast enough, we may even have telemetry and try and send signals over Wi-Fi.
Our current plan is to use two GM electric motors as our front drive, and then we have a Honda CFR 250R combustion engine on our rear drive. We're building a parallel split hybrid, so both of these drives will be connected through the road.
We get a lot more speed. It's instantaneous, whereas the mechanical version of a Formula car, you have to wait a couple seconds for it to come up to speed.
The goal is just to, press that accelerator pedal and get thrown back into your seat. There's 3 separate drive systems on the car. It's almost like we're trying to build 3 separate vehicles and integrate it into one. The idea of taking all of these things and, we have control systems for just managing the vehicle. We have power systems. I mean, we're dealing with 130 volts and lots of amps. It's a steel frame chassis. So you can't have it grounding out and then getting into your drive or anything like that.
One great success right off the bat was some really great support from GM, D-Space, MathWorks, and a lot of the University of Michigan College of Engineering departments.
We've been promised so much support, so much help, so many different materials. It's just a really great success for the team.
We had our recruiting events these past couple weeks, and we had over 120 people show interest in the group.
So we have a really good team foundation at this point.
Being on the team, we've had to learn about a lot of stuff that I haven't had past training in. My dad is into racing, but other than what I've observed from him, no, I didn't have any experience with cars.
I'm really interested in electric machines and drives, along with control systems. And this project utilizes both of those to a great extent. Being able to apply what I've learned through my EACS classes to an actual system that has real-world applications, I find that to be very beneficial. It looks really good on a resume, and it's a lot of fun.
What you can do with electric motors is just astounding, and I think you'll see people switching over them just for the fun of driving them, once you design them to be fun to drive. We're not only creating a car, but we're creating a team culture. And so no matter what industry you go into, being a part of this team or any of the other project teams at Michigan, you gain that sense and you understand how that culture works, and you can then figure out how to put your ideas forward and build something that's going to make the world a better place.